guys did the quiz last night.
Oh yeah. Well, we can.
Just erase it. We don't even want to think.
It's the weirdest stuff ever.
My husband.
Man over there.
Yeah, and women first.
Father-in-law.
Man, over
My
there.
daughter's
They
husband.
must have been role playing.
Son-in-law.
The beginning. Son-in-law. My daughter, my husband.
It's just sign language.
Man over there. Freak me out.
Then.
All right. So yeah, we can go over. We can still go over stuff from the quiz. We can go over stuff from the practice test, stuff from homework, general questions about how the hell things work, whatever.
The general rule on dividing the decimals.
Dividing decimals.
Dividing.
Yeah.
For example, the question number C on the practice test, it has 43.505 divided by 0.07. Or 0.7.
Gotcha. So, two things here, really. One of them is I can't really divide by decimals very easily. I can't think about how much does 0.7 go into 4. That's a little freaky. I can think about how much 7 goes into 40. That's much easier, right? So one thing we do is, normally when you see it written like this, it just becomes a rule of just the rule. What do? The rule is you move that over once, and you move that over once. If you have to move that over twice, you move that over twice. Because really what's going on is I'm multiplying the top and the bottom by 10. Whatever it takes to make this become whole, and then that guy, of course, you have to do the same thing to the top. That's why they move the same number of times. So that's one thing. And then the other thing that I'm still seeing, placement is key with this, because that's going to tell you where your decimal goes. So I still see people doing things like 7 goes into 43 6 times.
No, you got to put over 3.
Yeah, you got to put it over the 3, or else you're screwed from the beginning. Right? So it has to be the placement completely matters here. You did 7 into 43, not 7 into 4. So you have to put it over the 3 to represent the whole 43, and then the decimal is going to end up going right there. You don't have to think about it. You don't have to double check it, because you're not going to be able to double check it on the first part of the test. No calculators. There'll be 2 parts to the test.
So again, so if that was 70, then you put it, move it 2 times. However many times you need to move it over is what you do. And
Yeah.
do the same thing to the other side.
Yeah, so this, you just keep going like a normal long division. If I had 538.112 divided by 0.013, how many times do I have to move over the decimal place? 3 times. So 1, 2, 3. Wow. 1, 2, 3 there. 1, 2, 3 there. So then I'm doing 13 into 538.112. Yeah. And there's no, you don't have to worry about at the end. You don't have to say to yourself, oh, I moved it, so I have to move it back at the end. No. Math says that number is the exact same thing as this number. These are the same exact number. And we know that. That's a fundamental fact. If I multiply top and bottom of a fraction by something, I have not changed the number at all. I've just changed what that ratio looks like. So you do not have to think, what do I have to adjust at the end? No. This is the same as this would be. So you're done when you're done doing this long division. You don't have to move it anywhere back or anything. Is that cool?
That makes it.
I like it. Okay. Yeah.
On the square roots, you just want us to like answer it, or do you
Yeah, because on the square roots, you know that's one of the things I'm going to have on the part with no calculator. So I'm okay if you just give me the number. Because otherwise, there's not much to show me, right? Square root of 81, what would that be? 9. And you could say, because 9 times 9 is 81, but I mean, you just... So you guys should be able to look at it and just know it's 9, probably. Go ahead. Yeah.
So that's where you put the 9 because you know it's square root, right? In the little hook right there, is there a number that goes there, like 2?
There's an understood 2 there.
Understood 2, okay.
Yeah. But it's just because square root is the most used root. We said, let's not put a 2 in there. It's just, no, everybody knows there's a 2 there.
And
Yep.
any one. On any square root, there's a 2.
If there's not a number there in the
It's a
root,
two.
it's known to be a 2.
Can we do number C on this practice test? Or math test 4?
Part C of which, of where are we at?
Test 4?
Oh, you need one of those? Okay.
They didn't do it right.
Which one?
C.
The multiplying the decimals?
Right. I only brought wrong, or maybe I didn't bring my dot over far enough. I only brought 2 places. Okay.
All right, let's say we do this. What is it you have to be careful of when you multiply decimals? Good, I like it. You don't have to line up the decimals.
Forgot.
So that's something you don't have to be careful about. You just plop it on down there. It's just like 15 times 8. You're doing 15 times 8. You don't even worry about decimals till the end. So how do I know how many places over I'm going to go at the end?
You count.
Yeah, I know there's a total 1, 2, 3.
Right.
Which one is that?
This is Jeff's problem. So when you multiply this 15 times 8,
See from section
12.
and then you have to do 1, 2, 3, 1, 2, 3. So it's 0.12.
So on this one, it would have been 4 because there's 4 numbers.
Exactly. You just count. Yeah, I think on that one everybody had, well, there's 3 here. I can't remember doing 4.
Right?
No, there's 1, 2, 3. How many decimal places are there? 1, 2, 3.
But I'm counting this one.
Oh, if you add the 0, yes, you're right. Because you added that 0. You do not need to add that 0 in.
Mess me up.
Sort of. So if I have to do 2.7 times 0.13.
I thought 0 doesn't do nothing. It's just a place.
But what you did was not wrong, it was just not necessary. So if you think you have to line up the decimals, you would do this.
Is that
But all you're really doing is you're adding a 0, and see how, if I didn't do that, how many places would I have to move over?
Oh,
Yeah,
so I
right.
confused myself.
How many places do I have to move over at the end?
3.
3. And I don't have, I start writing the numbers. 1, 2, and keep going, right? You guys kind of with me? Now, if you add the 0 in because you think you're supposed to line the decimals up, it's going to have a 0 at the end. And then you're going to start with the 1, blah, 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 right? So this only needs to move over 3 because you didn't throw in this unnecessary 0. How many places does this have to move?
4.
1, 2, 3, 4. Just so I can go one more to get around that 0 that you didn't need.
So for that one you just did, I would do 3 times 7 and then 2 times 3 and then so on.
Yeah, so you multiply it just like you normally would, as if it was just 27 times 13. All right, so 1, carry the 2, this will be
Okay. 6,
Oh, you don't have to add the 0 to the end of
3 times 2 is 6 plus 2, 8.
8.
1 times 7, 1 times 2. So I get 351. And then I have to move it 1, 2, 3 places. So if you do this, you'll end up with 3510.
Number.
You'll end up at 3510. And you have to move it back 4 places. It'll still come out to be 0.351. So the process is built in. If you think you need to move it in, you're not going to mess yourself up. As long as you actually go back the right number of places, you'll be fine. When do you have to line the decimals up?
Adding.
Adding, subtracting, that's it. I like it.
F, one F. Count through the off. Yeah.
On the practice test.
That's what I was going to ask too.
Now, I noticed 2 to the second power.
0.2.
Yeah.
Oh, that's
But
where.
what makes the decimal move over? Is it the same theory as the 2 over? Are we moving the decimal 2 places?
So say again, sorry.
What makes that decimal move another place?
Because if you do, what does 0.2 squared mean? 0.2 times 0.2?
Yeah.
0.
So I have to move it once, twice?
Okay, so it's the same theory.
So it's going to be 1, 2.
Okay.
So 0.2 squared is 0.04. 0.2 times 0.2 is not 0.4.
And
Because what do I do to 0.2 to make it 0.4? I double it. 2 times 0.2 would be 0.4. 0.2 times 0.2 should be smaller than that, right? In fact, if I really, really look at it and overanalyze it, like I sometimes do, how do you write that as a fraction?
2/10.
2/10
It's 2/10.
times 2/10. 2 times 2?
4.
10 times 10? Hundreds. So wouldn't that be 4 hundredths? So that's why decimals, when you multiply them, you just keep track of how many places you got, because that's actually how many tens you're dividing by. And then whenever you divide by 10, what happens? It gets that many spaces smaller, however many tens you're dividing by.
Okay, keep going.
Yes. Oh, wait.
Yeah.
Let's finish this one out.
Yeah.
And then we'll do I. So you got 0.04 there, that's what that is. 0.04 there.
So it's gonna be 1.8.
Good, because this would be 1.84 minus 0.04, 1.8, but the bigger one's negative. So the top will be negative 1.8. And this is so useful. I know you can put this in your calculator, unless I put this kind of problem on the part 1. So a really cool thing to know is, do the same, just move that over. Multiply something divided by 10. Then it's just negative 18 divided by 3. Not a big deal. Negative 6. Right? So if you're dividing decimals, you already know that you're supposed to move the decimal over. It's just that when you get something like that, you don't even think about it. It doesn't look like that, because you're used to having like 5.89724 divided by 0.0765. You know, simple little thing like this, you forget. Oh, all I got to do is move this stupid decimal over. Easy. That looks freaky. That's easy. If I can write it, negative 6. Negative. So, one I. I like it.
Hold on a minute.
Yes.
The 1.8. You have 1.84 minus 1.04. I see the 8.
So I didn't line it up because I wasn't very careful.
Oh.
4 minus 4 is 0. 8.
Oh, it's mine. That's right.
And of course, the bigger one is negative, so that's why I made it negative 1.8.
Oh, okay.
They're different signs, so I subtract for
Right.
the sign of the bigger one back on.
I see that.
Cool.
What is this saying?
And real quick, little side note. Someday we'll get to part I. I'm having way too many people that are doing a problem like this, and somehow they're able to set it up like this and get somewhere. And that's, no, you can't do that. Unless you're really, trust me, you can't do that. You can try to force it. And I always get people that they just kind of are able to do this. I'm like, no. The way to do this problem is, it's two different signs. So you have to subtract bigger minus smaller. But you know at the end, you're going to put what sign on it? Negative sign. That is really the only way to do this without requiring a lot of trickery and a lot of creativity. Just turn that bad boy around. Now it's easy. Actually, that would just be...
But you can't take 6 away from 10.
Of course you can. What do you mean? You can take 6 away from 10.
So always
You can't take 10 away from 6. Not, yes you can, but with the extra pieces in there, it makes it really difficult to figure out how that all is going to work together. Right? We know what 6 minus 10 is. What's 6 minus 10?
You're going to be the negative.
Negative 4.
Well, that's better.
Right? But then how does this other stuff work? And how does it all come back together? That's what makes that difficult to do that way. So it's much, in fact, a lot of times, how do we do 6 minus 10? We know they're 4 apart, and we know it should come out negative. So we sort of do this in our heads already. So when you have decimals, you just do that explicitly for yourself.
So I'm sorry, you said you don't throw the 0 and then we have 10.20. No?
Oh, I didn't say a word about the 0. The 0 you definitely need. Because that threw some people off too. If you don't put that there, it looks like you're doing 2, and I had people give me like 1, and maybe the 7 just comes. I don't know. weird things.
So
But
you put the bigger number on top, always, or the bigger number?
yes,
Always.
yes.
It's a bigger number.
If I'm subtracting, if I have two numbers that are different signs,
What about if it's
I'm going to do bigger minus smaller. And now, what's the real? And so this is 4.03. So what's the answer to this? What's the answer to this? No, negative 4.03.
So you give me zero.
Because you put the sign back on.
Put the bigger sign back on.
So always the bigger number should be on top, right?
When you have sign.
What about
When you make it seem like that, it worries me because it only means that I've got two numbers that have different signs. That's
one
when
is negative and the other one is.
I like it. Then I agree with
What
you.
about they're like both negative?
Then it doesn't matter
It's
Just
gonna
add
be
up
negative.
because you add them and put the negative back on.
the negative.
Yes,
Got it.
right.
Plus a negative.
So if I had negative 2.12 minus 4.89,
You're gonna add it together.
just add those together and put the negative back on. Right?
Perfect.
Okay.
Always the bigger
Oh.
number should be on top.
What if it's like becomes a whole number to the left, right now, or right?
Say again.
If it becomes a like a whole number, like one, with the 10 instead of 2, which is 2 times 10, it moves to the, I'm confused where it moves to the right.
So here's the cool thing. I want you to realize, and there's so many little things that it's impossible to cram into a semester. But if you have a question like that, it makes me think about if I do 2 times 2. So let's say my beginning number is 2. If I multiply that by anything bigger than 1, my result would be bigger than 2, than where it started, right? So 2 times 2 is 4. It's bigger than 2. 2 times 1.5. 3, which is bigger than 2. So anything bigger than 1, it's going to come out bigger than it started. If I multiply by 1, it goes nowhere. If I multiply by less than 1, it must get smaller. So I think that's really the root of what you're asking. So since I multiplied 0.2 by 0.2, the answer has to be even smaller than 0.2 was to begin with, because I'm multiplying by something smaller than 1. If I multiply by something smaller than 1, I actually end up dividing by something. I don't know if you guys realize that. Because 0.2 is 2/10, so I'm actually kind of dividing that by a 10 in there. That's why it's going to get even smaller at the end. Does that make any sense at all? Shit. It's really an interesting point. So if you give me a number, maybe not 2,
20.
maybe let's say 6. Like,
5, 6, 0, 1.
if I want to make it bigger, what would I multiply it by? Anything bigger than 1. If I want to make it so anything bigger than 1 will make this bigger than 6. Is that okay if I write shorthand like that? 6 times 1.1 is 6.6, which is bigger than 6. 6 times a billion is 6 billion, which is bigger than 6. If I want it to stay the same, what would I multiply by? 1. If I want to make it get smaller, but not go negative, don't give me a negative number, just I want it to be positive but make it a smaller number.
That's negative.
0 is not positive,
Less than 1.
so I'd have to multiply by like
Half?
1/10.
1/10, yeah.
Or any decimal in between, or I can multiply by 0.5.
0.5.
What's 6 times 0.5?
3.
3. Right? Half of 6 is 3. 6 times 1/10 would be 6/10, 0.6. So if you multiply anything by a fraction between 0 and 1, you're going to get a smaller thing than what you started with. Does that make sense? If you multiply by, so anything, here's 1. Anything smaller than 1 is going to make it smaller. 1 is going to keep it the same. Anything more than 1 is going to make it bigger. Cool. Division is the exact opposite, because division is the opposite of multiplication. Right? I don't know if I want to go there right now. If you take something and divide it by something smaller than 1, it ends up getting bigger. If you divide it by 1, it stays the same. And if you divide it by something bigger than 1, it's going to get smaller. Right? So, for example, what's 6 divided by 2? That's neat, but it's 3.
What do you say?
12. 6 divided by anything bigger than 1 is going to make it smaller, of course. Division makes things smaller, or so we think. Of course, 6 divided by 1 is, that didn't make it smaller, it stayed the same. So 1 is that magic dude that if I multiply and divide, it keeps things the same. If I divide by 0.1, for example, something in between 0 and 1, how do I do that? I move it over
Once.
1, so I got to move this over.
Once.
So I end up with 60. 6 divided by 0.1, if you don't believe me, is 60. So if I divide by small, I end up big. If I divide by big, I end up small. Right? It's the opposite of multiplication because division is the opposite of multiplication. So that's kind of cool. Do you have to know any of this to be able to do math? No, but these are the kind of things that either you kind of notice yourselves or somebody tells you. But this is not something that's easy to sneak in unless that question comes up.
So what was the question again?
It was the one that has this as the answer. I am the original smartass, so don't come in with it. So what about 1i? Let me build up to 1i. What's the square root of 9? 3. Why? Because it takes 2 3's to make 9. 3 times 3 is 9. So the square root of 9 is 3. It's kind of like, square roots is kind of like cutting things into half, but multiplicatively. Right? Factoring them out. What's the square root of 25?
5.
So what's the square root of 9 over 25?
3/5.
3 over 5, yeah. Cool. So that square root is being applied to the 9 band and the 25 band. So don't let fractions and roots freak you out. You just apply it to the top and bottom.
So if it was percentages, you would then change it back to the fraction and then do square root.
Yeah, you can't apply a mathematical process onto a percentage. Remember how we kept having to translate it into a decimal when we were doing the translation into math from an English statement? So math doesn't like percentages unless you make a process that likes percentages. Normally math doesn't like percentages because it's hiding the over 100. I want to make the real number. So when I say 11%, that's not a real number. 11%, what's the real number associated with 11%? No, what's the real number associated with 11%?
0.
Yeah, 0.11, right? So you got to know which way to move those decimal points, right?
You always move to the right.
Not always. I mean, if you're going from percent to decimal, I agree with you. Sure. So remember, the percent number must always be bigger than the decimal number. See, that's a good thing too. It's like a after you've done something check. I just did something, and did it come out the way it was supposed to? Real quick word on this before I forget. How do I kind of check this? I would just say 3 times 3 is 9. How would I check this? 5 times 5 is 20. How would I check this? 3/5 times 3/5 is
9.
9/25. Check. Right.
Nice.
So that's why math doesn't really care if it's a fraction in there. You're still saying what fraction times itself makes this fraction. So we can just kind of attack it top and bottom. Bam.
Okay.
Anything else from homework, practice tests, quiz?
Question number 2.
Fill in the blanks.
Number 2? Yeah.
So let's see. I have. Okay. The fill in the blank one.
Yeah.
3 over 17 1/1000.
Yeah, I like this. Let's start with this one.
Very kind of you to give us that one.
What is that as a decimal?
3 and 17?
And you gotta go to the thousands place, right? And I got you. I heard. So tenths, hundredths, thousandths.
0.
And you gotta do the 0 there to make sure that we know it's gone far enough, right? So that's in the tenths, hundredths, thousands. Bam. That's it. That's 3 and 17 thousandths. So as a percent, don't make a big deal out of it. How do you go from decimal to percent?
Move it as
Some of you guys like this a little too much, but How do you go from decimal to percent? You go that way. You just write the letters D and B, decimal, percent. The direction you go to get from one letter to the other is the same way you take a decimal from what you're doing. So I am currently, as a decimal, I'm going to move it that way. Twice.
Twice.
Twice. Definitely always twice. Why is it always twice? Because percent means
100.
out of 100. And 100 is 2 tens. And that would be involved with moving the decimal twice.
Okay, got it.
I like it. But make sure, I never want anybody to just do it because I said so. I want it to make sense. Why does it work? It always has to make sense why it works that way. And if you have a teacher that won't tell you, screw them, find somebody else. They have to be able to explain to you why it works a certain way.
How about percentage 0.12 changing it to decimal?
I like it. So if I have 0.12%. So again, if you write that in alphabetical order, I'm currently in percent, so which way do I have to move my decimal? That way. I like it. Twice. All right, so to the left, to the left. So now you got 0, 0, 1, 2. I like it. And what is that as a fraction?
12 over 10,000.
Yeah, tenths, hundreds, thousands, 10,000s. Now, real quick word. What does percent mean again?
Part of 100.
Out of 100. So couldn't you just say this is 0.12 out of 100? Now, what's wrong with me writing that? What's wrong with that?
Is there something
There's a
wrong?
lot wrong with it. Especially because I'm asking for a fraction here. It's got to be a real fraction. And a fraction is specifically a ratio of 2 whole numbers. Do I have 2 whole numbers in that ratio? No. How do I make the one that's not whole, whole? What do I do to it? Move the decimal how many times? Once, twice.
Move it again, move that.
Once, twice. 12 over 10,000. The same damn thing I got there, right? You guys understand? You see what I'm saying? So you could go straight from percentage to fraction every time as long as you just adjust things if they're not whole. A fraction must have whole numbers inside of it. A ratio can be whatever the hell. A fraction is a specific kind of ratio. It has whole numbers in it.
What about the one that says 52%?
So 52%. So I'm in percentage, so how do I get to decimal? That way. So I got to go once, twice. Right, so that's a decimal. And then what would the fraction be? Either way you look at it, you're good, right? That's tenths, hundredths place, and percent means out of 100. So that would be 52 out of 100. And that would be 52 hundredths. So they both tell you the same thing. And I'm not really going to worry too much about reducing. In fact, I'd much rather see this fraction than the reduced fraction, because sometimes the reduced fraction means you found your fraction button on your calculator. And the calculator always gives it to you reduced. So if I just see the reduced number coming out of nowhere, I'm like, well, that came out of the calculator. Screw that.
How do you know?
Huh?
How do you know?
Because I know.
He's smart.
Especially when it's not the easiest fraction to reduce, and it just comes out of nowhere. So in general, you always show me work.
So you don't want to show me work. Okay. That's a point.
Yes.
Maybe somebody's taking this and do it right now.
Okay, what about the 3/5 one?
Yeah.
Is
I like this one. So if I have 3/5, there's 2 different ways to do this to go from here to decimal. You could just divide it, or even better, you can make it out of
1 over.
By 25? No, 20.
25?
So to take it to a percent, let's start there. To take it to a percent, I would make it out of 100. Because percent means out of 100. I'm with you. But I said take it to decimal. So that would be times 20. So up here, 60.
60.
So what percentage would that be?
60%.
60%. And then how to take that to a decimal?
0.
Yeah, move it once, twice, 0.6.
Oh,
You could put the 0 there if you want to, but you don't need it. I won't take points off if you put it there, but you don't need it. Right? 0.60 is the same thing as 0.6. Right? Right. Which one of these is bigger? Which one of those is bigger?
Same.
Trick question. They're both the same thing, right? They're equal to each other. Neither one of them is bigger.
The 0.
0 at the end does not change the value at all. You with me? What's 0.6 as a fraction?
6 over 2.
And what's 0.60 as a fraction?
6 over 100.
60.
60 over 100.
And of course that reduces to 6/10, which reduces both to 3/5. They're both the same number. For math, they're the exact same number. So it doesn't need those zeros at the end. You can put them there if you want to.
So the test is on Tuesday?
Yeah.
The test is on Tuesday?
Yes.
Why
Yes.
don't we do it by 20?
What's that?
Why don't we do it by 20?
What's that?
By 20, the last one, the bottom.
Oh! To take a fraction to a percentage, the easiest way to do it, if it's possible, is to make the bottom 100. Because what does percent mean? Percent, per 100.
Okay, but that's fine, but why do we tend to buy it?
Because how do you make 5 become 100?
Oh,
You multiply by 20. So you do whatever you need to the bottom to make it become 100.
okay.
Cool. Of course, whatever you do to the bottom, you have
Good to
to.
know.
I like it.
Can we check number 3 now? on the quiz.
Can we do all of them? Yeah, we.
What's that? Oh, I've already done all the ones on the practice test.
Sure, you can do all
No,
of
yeah,
them.
page
Uh-huh.
2. Into the second page.
Number 3.
What do you mean? There they are.
The keys.
Let me go ahead and give you this. Maybe this will help me out a little bit.
There we go, sir.
I'm trying to understand the process.
Answers, we like answers. Don't worry, we're all gonna get A's.
Yeah.
Is that both sides now for the practice test?
Yeah.
Because I couldn't print it out.
Okay.
I don't know. Sorry, I didn't get the flash. I don't know.
Oh, like I was saying, I'm going to put these kind of problems on the part that you can't use a calculator for, which would be okay for you to split. Yep. On the test, I'll probably have a blanket statement at the top that says, unless otherwise indicated, round to the nearest hundredth. So on a problem, if I say round this one to the 1,000th, you would do that. If I don't say, you would round it to the 100th spot. Does that make sense? There are a few on that practice test I didn't really say, and they kind of go forever. So I have to tell you where to stop. Yeah.
Number 8 on the practice test, what do you get the times 5?
I wish I knew. Oh, so I'm just making it, doing it like we did this thing, making it out of 100. So it's 20 right now, so multiply by 5 to make it out of 100.
What about number 9? Section 9. How do you get
Say again.
x equal 90? Number 9?
So if you do 0.45 times 200, that's what you'll get.
Sure.
So have you tried to do it yet? There you go.
So I did that one different. And I
Try it
thought
out.
this-
If it doesn't work out, then I'll answer. I like it. Yeah. I like it. But it's not a percentage. Be really careful. It's not a, so you know
What
the
is-
percentage. You're looking for the number. What is 45%? So it's, this one, I don't know what the percent is. So you better end up with a percentage.
So this one is
Yeah, your
asking
answer
for a
has to be a
percentage.
percentage. Yeah.
They didn't finish working this one out, so they didn't know if I was on the right track.
Yeah, it looks like you are. Just be careful about when to throw that percent sign on there. Oh yeah, I just skipped the 3 goes into 3 once. Because that one even, so I did 3 to 31 is 10.
Oh,
Just to kind of cut a little
Okay.
right now. Say again? Oh, because here's your next step. To solve for x, you divide by 180.
Oh.
You just
okay.
built in, when you do it this way, the times 100 is built in. Me, I got a decimal and then had to multiply by 100. Whichever way makes more sense. Yep. That's the tenths.
Right. And then that would go up to 8.
For C? Yeah. That's tens. Here's the ones. So it takes them.
Oh. No. Tens. We were 20.
So which numbers in the tens?
46.
No, that's the tenths. Which number's in the tens? The 1. And the number next to it is a 7, so it would go up. That's the 1, yeah. No, that's the ones. What number's in the tens spot is the 1. Alright, so
The one.
So,
Thought I did.
guys, up here, this number, which number is in the tens spot? 3. 3. So if I ask you to round to the tens, or if I ask you to round to anything, you find that, and then you look at the number next to it. So if I round it to the tens,
0.
yeah, this part would become, so it'd be 440. I like it.
0. Yeah. That's it.
That's it.
What about number 26, 87?
They're all zeros now.
0.
Because you rounded it. If you round it, you make it round. You make it zeros at the end. Yeah, so everything else becomes zero. So if you want to do the ones, what number's in the ones place?
5.
Yeah, the 5 is in the ones place. So you look at the next number.
So we'll be 10.
So that's going to become 6. So it'll be 436. Done. Right?
And 0.
If you really want to, but I don't want to really say. You don't need those. You don't.
What about 6?
What about?
5 or 10?
What's the 6 then?
Are you asking what place is that in?
10.
Yeah, that's tenths. And then hundredths, and then thousandths.
Is there
Yeah.
ever a time then that the 68 would become a 69?
Yeah. If you round this to the hundreds, what number is in the hundredths spot? 8. So then you look at the next number. You look at the next number, and what's it tell you to do this?
Put it in a
690.
So it'll be 435.69. And what is it to the hundreds? Hundreds. Yeah, the 4, so the 3 tells you to do what with this?
Keep the same.
Keep them the same. So it'll be 400. And it'd be really evil to ask you to do the thousands. Thousands. That's exceptionally evil.
Would it all be 0?
Yeah, it would be 0. The closest thousand to that is it's going to be either 1,000 or no thousand.
Sacred geometry.
And it's closer to no thousand. Don't worry, I won't give you that one. That's kind of freaky.
I love extra credit.
Huh? Sure. That could very well show up with X credit. Or something maybe a little harder than that now. Yeah.
No.
What's up?
Just give them some space.
Yeah, but okay. All right.
See you later.
Is that correct?
No.
Oh my gosh.
So 28. You'd say if I went around it to the tens, you'd say that's about 30, right? It's about 30. Just because I have 28.1, that 0.1 should not change my rounding. 28.1 is still about 30. It's close. Do you understand? What other number would round to 30? If I rounded it into 10 spot, what other number would round to 30? 25 would. 26 would. Every single number in between 25 and 34, and actually even more than that, 34.9999 forever, every single number in between there would round to 30. Every number. So 27.894426666532 would round to 30. Right? I don't care about the numbers after. I want to make that number whole. I want to make it round. I want to make this stuff at the end zeros. I don't want to carry all that crap around with me, because the main reason we use rounding for is to get estimates. So if I have 28.17652, I do not want to say that's approximately 30.17652. I've lost the whole purpose. There's no point to rounding then if I carry that stuff around. That doesn't even make sense. That's closer to 30 than it is to 30 point something. Right? So whenever you round to a place, everything else becomes zeros in those places. So if you're rounding to the tens, that would become a 3. Everything else becomes zeros. And what I'm saying is you don't need those, of course. Right? So you become a nice, round number. Okay.
My light bulb just came on.
I like it. One light bulb at a time.
So if you're doing like you were saying, round to the nearest hundredths,
Yeah.
then that would become 28.18.
So the round, where's in the hundredths place?
7.
7. So the next one's bigger than, is 5 or bigger? So yeah, it'd be 28.18. Cool. Hey, Robert, Corinne. If I said 435, round that to the nearest hundreds.
There is 400.
So you wouldn't do that again, would you? Everything after that point becomes zeros. Otherwise, it doesn't make any sense. You just repeat the same number again. So that's exactly what happens to all these. The same thing happens to all those numbers. If I'm rounding to this place, all those become zeros for the exact same reason. Cool. All right. One more light bulb. George Bush is 1,000 points alive. Remember that? You remember? The first George Bush, the one I could actually talk.
I hope it stays lit.
Oh yeah,
I
that's
hate when that
that's
happens. Like it's on and then it fades.
that's the hardest thing
Keeping it lit.
as a teacher is to find a way to make it stay lit. Once you, yeah, well, that doesn't sound right. Make sure when you leave my classroom that you stay lit. Wait,
And don't drink and drive.
that's. Hey Dean, if my Dean's watching. Hey Dean. Let me check on Jeff. Let me evaluate his teacher. Oh. I like that you guys are just going. I like it.
6 a.m.
Well, everybody's working. I love it. I've no, maybe you're working on an English essay. I don't know, but which one?
The 6A, the unknown, finding the unknown length.
6A. Oh, the Pythagorean. I got you. Let's do kind of a lightning round of these.
What'd you call these? Pythagoreans?
Who?
Where we
Pythagorean
at?
theorem.
X5. Where we at?
Doing some practice. Also, like number 6A.
I like it, but screws.
Oh.
So, the general idea, and of course, what's the most important side?
The long.
Probably the one I haven't written yet, right? So across from the largest angle is the what? The C, which is also known as the
Hypotenuse.
hypotenuse. I love it. Right? And of course, the relationship that was discovered is a squared plus b squared equals c squared. And we talked about those squares that actually hang off the sides of the triangle. That might make it stick in your head better. It is a bunch of squares that you're adding up to make the biggest square up there, right? If you missed that lecture, you have no idea what I just said. But sorry. So how do I set this one up? Which one's C? X. Good. So X is going to be by itself. So the other two squared added together, I love it. 3 squared is
25 equal x 34 equal x
not divide by 2.
by 1.
No.
You can't divide by X because then you can't get a number. How do you undo a square? Square root. And then you can do that in the calculator. So that's actually the same problem. That's the problem on there. So you have that answer on there. So
Why do you let
5
it
point something or other.
What is that equals X? That just stays equals
There's
X.
still 2X.
No, you still have to
Divided by
figure it out.
No, watch. What's the square root of 9?
3.
3, because 3 times 3 is 9. What's the square root of X squared? It's X, because X times X is... And the quicker way is the square root and the square cancel each other. Because they're opposite. Square roots undo what squares do.
Yeah.
So the cube root of X cubed square root of X squared, they cancel. Cube root of X cubed, they cancel. It's X.
How did you get that 5.831?
Just approximately that. Just in your calculator, square root of 34. There's no way, there's no real good way to do that by hand. There is something you use to approximate it, but the calculator will give you the best
So
approximation.
whatever you get from the two numbers being squared, you're automatically going to put that square root symbol in the number.
Well, I'm
inside
solving
that
the
you-
equation. Now, here's the cool thing. How do I solve any equation? Basically, solving an equation, the quickest way to describe it to somebody is you keep doing the opposite, right? If it's x plus 7 equals something, I subtract 7. If it's x divided by 4, I multiply by 4. You guys with me? So what's the opposite of square? Square root. So I'm still applying the basic idea of solving equations, which is if your x is not by itself, you do the opposite thing.
Always?
Always.
Always.
Hell yeah. Man. I didn't know that, Mr. Pollard. You say it every time. You have a shirt that even says it. I didn't know. All right, how do I set that one up?
11 square, 15 square. C square equals 11.
Which one's going to be by itself?
X.
No.
15.
Which one is the hypotenuse? 15. Oh.
X is not all.
That's the biggest dude. If the biggest dude should have come from the other two dudes added together, right?
So the hypotenuse.
So that guy squared must have come from
11 squared X squared.
Oh, 11.
So what's 11 squared?
121.
No.
4 something?
225 there. That's what. Now how do you solve this equation? Keep going. It's nothing. I love it. I love it. So, I mean, just because I have a square in there doesn't mean a damn thing. I know I got to move that the hell out of the way. That's on the wrong side.
Minus 20. Minus 20. Will be 1 out for 2.
Take a square root. Because my x is not by itself. It's got that stupid little square hanging over it. So I square root it and I kill it. So I get x equals 10 point something.
I don't have my calculator, but you put in the number and then hit square.
It depends on what kind you have. If you have a scientific calculator, you would hit the square root button first, and then it'll show up on your screen with the cursor blinking in the middle, and then you put the number in. If you have a really basic calculator where like the square root is the most advanced thing on it, then you hit your number first and then hit the square root. I didn't mean that in a bad way. What you want to do is a scientific calculator costs about $15. And it can do, the one I got was $15. It could do like 400 things. So go ahead and grab one of those. Get used to it, right? Don't get that. If you have the money now, if you have a way to do it, you might as well get a TI, 83 or 84, Texas Instruments, a graphing calculator.
And we're going to need one.
You'll need one if you're going to take 110. Some of you guys might eventually take 103, and you don't really need one for 103.
So we don't need one for this calculators?
A graphing calculator? No.
What about the final?
What about the final?
No calculator for you. Just for you.
I like calculator Nazi. No calculator for you. Come back 1 year. Seinfeld reference. Sorry, that's way before most of you guys. Fine, on this earth. All right. Some of us didn't find it funny. That's why you didn't know what that was. So what was the square root of 104? Did somebody do that?
10.98.
1/8 stuff?
190.
198 stuff?
Yeah. Just
All right.
put stuff.
And then finally, the last dude, how's that going to work? Well, who's by himself?
24.
Yeah, the 24 is by itself because it's across from the right angle.
X in the beginning.
X squared plus
21 squared.
21 squared.
21.
Yeah.
441, I like it. 24 squared.
576.
And then, of course, you
Minus
subtract, right?
441.
So that's easy. 135.
And
And then we need square root.
Square root, so you can kill that square.
11.61. 11.61.
Blah, blah, blah. Okay.
And we did 2 into 135.
Say again?
Then we did the 2 into 135.
We did a square root of 135. Coolness. So don't just automatically put the x squared by itself. It completely depends on where it is. It's the hypotenuse number that's supposed to be by itself, equal to the other two added. Because that's the longest side. It should be equal to the other two added.
Isn't the bottom side technically as long as the hypotenuse side?
Definitely not.
No?
If you think about it, the minute, so that is that long, right? The minute I lift it up, it doesn't come down. The point here is not as far as it would have been there. See that? So the minute I lift it up, that top has got to be a little bit longer, because if I push it back down, it's going to come over a little bit. Back here, it would come over by exactly 3. That's the neat thing about that.
So the long side, the hypotenuse side, always goes on this side of the equal sign.
Always is by itself.
By itself.
Exactly. It's going to be equal to the other 2 smaller side squares added together, which makes sense. The other 2 smaller sides squared added together makes the bigger side squared. That makes sense.
So you, like in this one, you gave us 24.
Yeah, the
sides
bigger
of the
side
saw.
squared is the 2 smaller sides squared added together. The 2 smaller sides get together and make the bigger side when they add their squares.
That's a maybe. We got this. Can we do one last one?
I like that. You're speaking for everybody. This is the last question. Nobody else. Yeah.
The number 9, 8.
9A?
Oh, yeah, this way. How do you get the 9?
Because you multiply. So, what is 45% of 200? So 45%, isn't that almost half? You with me?
Yeah.
What's half of 200? 100. So I expect my answer to be just a little bit below 100. And then it would make sense. So if my answer is 2, I know something went bad, right? So how do I set this up into a math equation?
Divide by 2.
What is 45%? 0.45 of means multiply 200. Now just multiply those two. 90. Yes.
80%.
Not percent. This is a number, that's a number. This is the only one that would be percent. So like on part B, I don't know the percent. So that would have to get a percentage symbol on it. This is supposed to be just a pure number. Good.
I got it.
Part B. So if I have 72 is what percent of 180, right? So how does that look as an equation? 72 equals
X.
what percent? So I put X. Of means means multiply 180. So 72 is what percent of 180?
So what is the number?
Second.
It's like 180 and 180. Oh, 72 over 180.
Yeah, so you divide by 180.
And this, the other one too?
Well, whatever you do on one side, you got to the other side.
Make it even.
And then you just do this in your calculator and you get something.
200. X equals 0.4.
0.4.
And 40%.
And then how do you make that into percentage? Because that's the question, right? What percent?
Over 2.
Exactly. Once, twice, so it's 40%.
Nice.
And again, that makes sense because half of 180 would be 90. So 72 must be less than half of 180. So it's actually 40, not 50. It's 40% of 180. It's less than half of 180. So again, that answer makes sense. If I got that it was 90%, I'd say, well, something went wrong. It's not even half of that. How could it be 90% of that?
That's good. You can actually check a price that a store is trying to sell you. When
Because they make mistakes.
yeah. They're
Sometimes
telling
not on purpose.
you- Yeah.
Sometimes on purpose.
They weren't educated.
I think a lot of times it's on purpose.
Yeah, could be.
Because
Because they know people don't check.
Yeah.
People don't check the change either. From spitting out of the machine can make a mistake. Check your change, including any slugs.
You're shorting me a penny.
What's that?
I said you showed me a penny. Kidding.
Penny shouldn't exist anymore, man.
Go back on one more step on that. When you have, here you have it set up 72 over 180 equals X over 180, and then you brought the other 180
No.
in.
The beginning point was 72 is what percent of 180? That was where I started. That was the math that's translated directly from this English.
Okay.
72 is what percent of, means multiplied, I don't know what percent, times 180. And then I just solved that for us. Now, a lot of you guys can just realize that you take 72 divided by 180 because getting a percentage. 72 out of 180. And that's fine if you just go straight to there. If you're not comfortable doing that, you can always just go straight to the math and then just start attacking the equation. We've done enough equations. My hope is that you come out of this class not scared by equations themselves, just scared possibly by what might be in them, right? You put uglier and uglier things in there and you're like, oh shit. But it's the equations themselves, you should know how to attack them. Yeah. Oh, did you?
Yeah, how would I figure out the square root of 9 over 25?
Oh, we
Came in late.
okay.
Sorry, guys.
That's right, that's right. So, what's the square root of 9? 3. And what's the square root of 25?
5.
So, what's the square root of 9 over 25?
3 over 5.
Because again, 3 times 3 is 9. That's why that makes sense. 5 times 5 is 25. That's why that makes sense. 3/5 times 3/5 is 9/25. That's why that makes sense. So you can attack a root of a fraction piece by piece. Which is kind of nice. The thing you cannot do
Oh no, I'm going to see it and I'm going to do it.
is say that that's 2 plus 3. And that's the biggest mistake across almost every course I teach up to 285. I get this all the time, and when somebody in my calculus class does this, it makes me a little tear. You guys, if you did this somewhere, we haven't even talked about this until right now, so I couldn't really hold this against you. I'm not going to have something like this on the test, but just to make a point of this right now, this square root has an understood parentheses here. You have to do what's inside of it first. That square root symbol is like there's an inside to it. We know order operations is you do the inside stuff first, right? Square roots can't distribute to each piece. They don't work that way. So you can't say this is 2 plus 3. No. Right square root of 4 is 2, square root of 9 is 3? No. This is square root of 13, which is some ugly number.
I don't even know how you...
Nothing personal. This is not a whole. You guys kind of with me?
But they're not always going to be that easy, right?
How do you-
What if the fraction, what if the square root isn't?
Oh, then what you do is this. I'll show you. What you do is, this happens a lot in math. A lot of times in math, you get a top that you can't do, but the bottom you can. So then what's the square root of 16? 4. What's the square root of 29? Square root of 29. Because I don't know what the hell it is, right? Now you could then take it to decimal, but most of the time we stop there, because then if I want to do other things with it, I don't want to approximate it yet. You kind of with me? So you do the part you can do, and you leave the part you can't. Again, I am probably not going to have something like that on the test. Maybe something a little worse than that as a bonus, but with that idea. Right.
Well, with addition, we can't do that, right?
Yeah, addition, you can't do that, because roots are the opposite of, or the inverse of exponents. So they actually are in the same kind of place in the order of operations, but that's why these implied parentheses is good to know that. Exponents are based on what operation? Multiplication, division. So exponents work really nicely with multiplication, division, right? So roots work really nicely with division and multiplication. So if I had square root of 25 times, what you got, Jeff? 49. I could definitely say this all day, that that's the square root of 25, square root of 49, which is 5 times 7, which is 35. And if you want to check me, what's 25 times 49, and then do the square root of it, you're going to get this big-ass number, take the square root, you're going to end up with 35. So roots act really nicely. They play real nice with multiplication and division because they're based on multiplication, division. Same way with exponents, they play real nice. I don't know, I might have went too far.
So you times that square root by that square root.
Yes. So you can break it up that way, but they are never going to play nice with addition because they're not based on addition. What plays real nice with addition? Coefficients. That's real easy, isn't it? Because coefficients are based on addition. That's why it's so easy. But this, you can't just say it's x squared plus 49. No, you cannot do that. This is ahead of us, but you'd actually have to write it out like that. And some of you guys might know to do something called FOIL method on that. It's all complicated. But you cannot just say I square each piece. You can't do that. Exponents do not play well with addition. Why not? They're not based on addition. They're based on multiplication. That's the thing I think a lot of people never get told. You're never told that that's true. That's exactly why these properties work the way they do. A couple of these things are ahead of where we are currently. But they're in the future, and they kind of deal with what we're doing right now. So, yeah. Next semester, basically.
You're a good teacher, man.
I don't know. Sometimes I feel like I go a little too far, but because then you get worried about when's that going to happen. It ain't going to happen this semester. But that's more of the whole story. Yeah.
What there is now, so then now.
By the way, guys, here's now that the whole schedule's up. I meant to do this last time.
What do you mean the whole thing?
Back when we last talked about teachers to take next semester, since I'm not going to be teaching 90, I only knew the full-timers that would be teaching. But now I know everybody. So, you ready? Yeah. So there's one 7:25 in the morning. So if you want to do that, Richard Hardiman is really good. I don't think he's teaching at a different time though. I taught once at that time, and my brain showed up about half an hour after I got it. Corey Manchester, I think he's teaching one that's linked, so you can't take him. Sarah Wilwood.
Sarah Willow.
Wilwood. If you've ever taken Sarah or know Sarah, she's really cool. Students love her to death. She's teaching at 8 a.m. It's a little bit better than 7:25.
How you spell her in one wiggle?
Will, W-I-L-L. And then W-E-V-E-R.
Oh, Willover.
Wilwood.
Okay.
Is that night course?
What's her
No.
time?
8 in the morning.
Oh.
Are most of you guys going to be night again next semester? Because the unfortunate thing about next semester is they have a 5 o'clock class, and then they have a 7 o'clock class. There's like no 5:30 class. Right? So they have a 5 o'clock class that I highly recommend with Mr. Wynn, W-I-N-N. Students like him. I would say don't take, well, I'm not going to say who not to. I don't know the guy that teaches at 7:30, and I would not take the guy that teaches at 7.
What's his name?
Blunt.
So
Why?
not
Imami.
7:30, right?
What?
E-M-A-M-I. Of course, this is all on tape. And then beyond that, it's just the people that I told you last time, because I don't know the other guys. So I don't know if that probably bummed you out or anything. Sorry.
Like I said, we'll just bring our work. Find you. We'll find you.
That's funny.
Don't let
So you'll show up to the office hours when I'm not your teacher, but not when I am your teacher.
No,
I understand. Nobody ever wants to see me.
No, I need to learn more.
Six three, number 12.
I need to speak to you after class, Mr. Wallace.
Okay.
Okay.
So Ramona Hatch has enough money. So this is page 427, number 12. Ramona Hatch has enough money to put 6.9 gallons of gas in her Honda Civic Hybrid. And they make very specific word problems nowadays. It's red, by the way. It says so in my teacher's edition. She's planning on driving home from college for the weekend. If her home is 290 miles away, she lives 290 miles away. Now this actually happened to me several times in my life, where I'm like, I want to go see my mom for the holidays, but I've got this much money. And so I had to think, okay, how much gas is it going to take to get home? Do I have to rely on the kindness of strangers? Thankfully, it's all over. Should she make it home before she runs out of gas? A Honda, they tell you in the beginning, it averages 627 miles on a 12.3 gallon tank. Right, so they get pretty far. So how do I set up this problem?
6.9 miles.
So what can I set up from this?
What miles I'm talking about?
If you want to, sure. 627 miles, 12.3 gallons.
You're gonna put X.
X over 29 miles.
Definitely not. Yeah. For two things. That's what she's actually putting in her tank. And the gallons is what's on the bottom.
Yes.
Now, if you want to put 290, you have to put it up there, but then you have to kind of interpret it differently how you see it. So either can say, I can put that much in, how far can I make it? Or I could say, let me put that number in and put an X there and see how many gallons would it take me to get home.
But he said it's harder to do it when the accident.
Either way,
How'd you get to 627?
they gave it to me.
Where's that?
In the book. Yeah, in italics, right above the problems.
Well, yeah, but I was looking for it on the board. I didn't see it.
Oh, there it is.
Okay.
So it tells me the Honda Civic, it's that.
Okay.
Right? And now you just cross multiply if you want to. And again, some of you guys might realize the X is already up there. You just have to multiply the 6.9 up, and you've got X by itself. Or you can just always cross multiply, however you want to do it. Is that cool?
Cool.
Does that work out? Yep. So you should get that she can make it. She can make it with some distance to spare, and hopefully she can borrow some money so she can make it back home.
The other way, right? The first time?
Yeah, you could have flipped both of these. As long as if it's miles gallons, better than miles gallons here, or vice versa. Okay.
You got this.
If you're interested, have I ever shown you this trick? Or if you had to do something like this? Pretty sure I showed you this. Not a trick, it's just the way math works. When I subtract to see the distance between two numbers, So if I make that number go to 999, to have the same answer, I've got to make this go to 316. Right, so the distance between 2 and 5 is the same as the distance between 3 and 6. Right, so if I move one, I got to move the other one the same way. Now, what's really nice is that has a lot of freaking borrowing. This one has no borrowing. Right? So this is a hell of a lot easier to do. You with me? So this would be, I can just start at this side. There's no borrowing to do. So it would be 683. So the same, if I had to do 12 minus 0.19276, you guys realize how much that would suck? It'd be 12 point, you have to put the minus 0.19276. I mean, that's a lot of freaking borrowing. Whereas what's one number down from this? It would be 11.99999. So I'd make it 11.99999. As long as I make this number become 19275. If I move them in the same direction,
One goes up, one goes down.
if one goes down, the other one's got to go down. So that they stay the same distance apart. 0.19275.
Can you do that to any number?
Anything where it helps. You can do that to any number. Any number ever. When you have subtractions, you can do that all the damn time.
Just subtract.
But where would I do it? Where it helps.
Just subtraction.
Yeah, well, if you do addition, if you make one number go down, the other number's got to go up, so that it averages back out, right? Like 2 plus 5 is 7. 2 plus 5 is 7. 3 plus 4. See how that one went up, this one went down? And now we're getting a little bit... That's not nearly as useful as this. This is useful here. And then it's easy. 11.80724, yay.
Yay, you know it.
So if you want to use that on the part that you can't use a calculator on, that's awesome. You got to know how to borrow, but it's even better to know how to make the damn thing easier in the first place. Be real careful. If you don't fully understand that, never use it. All right?
What do we want to try it?
Then try it when you have a safety net. And then check yourself and make sure you really understand
You
it.
got one in here?
Don't try it when you're...
If
taking the test.
If the question says like that, originally, the problem is that with the 12 point with all the zeros, and then you use that method there.
Yep.
And come up with that number. That's not going to be correct, is it?
Was there
Of course not. That's the right answer.
It is.
Do this with the calculator.
They changed the numbers.
It sounds like you changed the number.
But now watch.
You got any?
What's 7 minus 2? 5. Right, so 7 minus 2 is 5. Well, what if I make 7 become 6? And I make 2 become 1? Did I change the answer? It's still 5, of course, because what is subtraction doing? How far apart are these? So if I move this one down by a little bit, I just move him down by the same amount, and it's the same stupid answer. Math goes, I don't know what just happened, I'm cool with that.
The last number?
Yes, in this case, the last number. You can generalize this and do a lot more with this idea, but this is where the idea is most practical.
Is there anything on here that we can apply that?
Not really.
I want to know.
Guess number.
I want to practice.
And a safety net.
Number 1B.
B, maybe?
Yeah, 1B.
Yeah, we'll be.
B.
You can make it
Just remember, you got to put the 11.2 first.
the bigger.
Subtract the smaller one from the bigger one. Yeah.
Well, 11 is going to be a 10.
No, careful.
No.
It's 11.2, right?
11.
So write it out first.
11.2.
So see that 1B?
Yeah, I see it.
So it'd be
127.
so of course what do I have to put here?
0.
So if I take this to the next number down from 11.200,
Everyone.
it'd be 11.199. You with me? Isn't that directly below 200? 199. So then I have to take this one down to 5.126. Now in this example, it's not a lot of zeros, so it shouldn't really It's almost like the same amount of work either way you do it. But if you have a bunch of zeros there, screw that. I'm going to make them all freaking 9s. Right? So then now you can just go this way. 6 points.
0, 7, 3.
Yay! And then,
So
of course,
you
that's
didn't
not
mess
the
with the whole number.
And then he goes negative 6.07.
Okay.
Cool.
Right. You didn't mess with the whole number. You just.
Exactly. Didn't need to. The only reason the whole number changed here is because these are all zeros. I have to flip back to 11 point. Right?
Right.
Because the next number below 0 is like 99. You know, and then I have to do the next number below 12. What would that be? 1,200,000.
Okay.
So it's a neat option.
I'm gonna try that. On the test.
Do what you like.
I might get over it. I won't know until I try.
And also, just to show you, remember the problem I had earlier, the 0.45 times 200? So when you divide, if I move this over once, I've got to move that over once also, right? When you multiply, it's the opposite thing. If I move that over once, twice, I got to move this back once, twice. That should kind of make sense. What's 10 times 2? 20. If I make that become 4, if I make this one bigger and make it 4,
40.
what has to go here to make this stay 20? What times 4 is 20?
5.
5. So I have to make, if 2 goes up to 4, 10's got to go down to 5, so they still multiply by the same thing. You're trying to average it out. So when I multiply, if I take one this way, I've got to take the other one back. So then I end up with 45 times 2, which is really easy to see that that's 90. So that's what I do in my head. When I see decimal times a number, I just move the decimal over until it becomes easy.
To the right.
Now again, do not take this as me saying you have to do that. No. If you happen to see that that makes sense, kick ass. If it doesn't make sense, no problem. You don't have to understand that. It's just a neat thing that numbers do.
Just remember that song. To the right, to the left.
To the left. Of course, if at any point you feel you are ready for the test, you certainly don't have to stay here for any reason, right? Don't feel like I'm keep my eyes on you. But if you're not quite ready for the test, then stay and ask questions.
So, on D, can we apply that?
Yeah. But on D, it doesn't really help out a lot. Because if you want to make that 0.015 bigger, then the 12.31 gets smaller, and it's kind of like, here this is nice because you have a much bigger number here. It's got a lot of room to become smaller. Does that make sense? Whereas there, 12 doesn't have a lot of room to become smaller. Before you know it, it's a decimal itself, you know? So
does the left side, or does this side of the problem always move to...
no. So if I had a problem like 5,000 times 0.03, right?
Right.
Oh, yeah, there's several curves here. Yep. Cool. Like it.
Is that one?
The 5? Yeah.
Yeah. So we've only got
That's right.
So we're not doing
I just began.
genetically we're going to go into.
No, yeah.
That's just scraps. So just not.
Scrub, totally.
Yeah, it's got these two left. And that's
Yep, that's it.
Cool. All right.
So how many times do you have to move the decimal here to make it whole? 2 times. So once, twice. So this one's got to go back once, twice. So now I have 50 times 3.
So we want to make it a small.
Yep. So on the problem with the test is just neither number is big enough or whole enough, round enough to really play around with it, So that's, if this was 5,001, this wouldn't really help me out a lot. Because it's 5,000, if I move the decimal, I'm kind of like losing zeros. They're gone. It makes it a much easier number to work with. But if there's a 1 there, it would be 50.01. That didn't really help me,
I want to set up a problem, 9B on the quiz. Would I set it up as 72 equals?
Okay.
72 equals X times 180.
Beautiful. And then just solve for X. So since it's X times 180, what would you do to kill the 180? You would, right, to solve for X, how would you get rid of that 180?
Subtract.
No. What's the operation?
Or multiply.
How do you undo multiplication?
Divide.
Yeah, there you got to divide. Yeah.
And number C on the practice test.
In which part?
The first
Yeah.
you times all those numbers by 10 to get them to equal numbers.
Yeah, I multiply top and bottom by 10. Because it's written as a division, but wouldn't that really be 3.505 over 0.7? So, okay. If I give you a division problem, set up as a division problem, there's a rule. So if I had like 0.07 into 5.629.
I don't think we're on the same.
Yes, we are. Believe it or not. You're talking about the 40...
No.
You're talking about 43.505.
I'm sorry, I meant number 4 letters.
Oh.
I'm sorry.
No, yeah, that's
C.
Oh.
question too.
Okay.
Yes, we-
I thought you were saying something about the 43.505.
No, 4C.
Yeah, 4C, I'm sorry.
So 4C,
4 times 2 just means 8. Why it's 9?
2.3.
because you're not multiplying 4 times 2, are you?
2.3.